In the Autodesk Inventor model, I've applied constraints so that the scoop is behaving correctly. It's moving around the axis of the shaft. However, in your model, the actual robot, you're going to have to place a lock bar. Here's the lock bar, and I'm going to constrain that to the shaft and to the scoop bucket. The first constraint I'm going to place is an angle constraint between the face of the shaft and one of the faces on the inside of the lock bar. This will align the lock bar to the shaft and to all the other components on the shaft assembly. I have some circular edges I can use, so I can apply an insert constraint. That's that extruded surface and the edge of the lock bar, and that constrains the lock bar correctly. To attach the lock bar to the bucket, I'm going to place a subassembly. That's 832 times 500 underscore lock bar. So that's provided for you. To make it easier, I've turned off the visibility of that C channel. I'm not going to use eye-mates in this case. I have some circular edges, so I'm going to constrain that. One axis, then the other. Click OK. I need to move that out a little bit so I can get the other face. And I'm just going to apply a mate constraint between the face of the cap screw and the face of the scoop bucket. There we go. So that's that first one in place. You're going to have to do that 3 more times on that lock bar. You're going to place a lock bar on the other side and place that subassembly 2 more times. Don't forget to turn back on the visibility of that C channel. I've placed the other lock bar and the 2 subassemblies with the cap screw and the caps nut. I've also added some other subassemblies here, and that completes the frame. And the name of that subassembly is 832 times 250 underscore scoop frame. And again, that's provided for you, so it's pretty quick in terms of completing that.